Welcome, my friends, and welcome to Chapter 6. This will be our introduction to the material. I don't intend to work any problems in this short video, but just to introduce a couple ideas, get a couple notes down. So this is Chapter 6. Chapter 6 has to do with trusses, frames, and machines. We're going to start our discussion dealing with trusses. So I've got a picture of a truss here. I get it, it's not perfect. If you're looking for perfection, you can look at your author's renderings on page 101. The top picture on the right-hand corner is a perfect picture of a truss. But this is going to do for our discussion. I promise that as we work together over the next couple weeks with trusses and frames and machines, my drawings will get better. I think many of us are familiar with trusses. I want you to take a couple seconds and think about where you have seen trusses. In your lives. I know, like, for example, this morning I was the ceiling fan in my son's bedroom. The light won't work anymore, so we bought a new ceiling fan, and today was the day that we we're going to install it, and go to install the bracket that holds the ceiling fan to the ceiling. Get discombobulated, kind of forget the orientation of the support bracket that's up in the attic. I have to go in the attic, poke my head in the attic, wham bam, trusses are up there in my attic. I've heard students talk about trusses that they have seen. I've had some students that were carpenters, and they floor joists they render as trusses. Scaffolding around buildings would be examples of trusses. So just a couple real life examples. Now, there are some things, trusses share several characteristics. So I want to talk about those real quick. I've got 6 characteristics up there. The first characteristic is they are completely made up of 2 force members. So let me go over here and kind of draw a little bit so we can talk about it. I'm going to call this point A, B, C, D, and E. So as I look at this truss, I see there are several members. So the members in this truss are AB, AE, BC, BE, CE, ED, and CD. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this truss has 7 members, what we call members. Each of these members is a 2 force member. So I'm going to draw, for example, AB. This is AB. Let me erase that. That is hideous. You guys deserve better than that. So member AB. AB is a 2 force member. That means that either there's a force acting on the B end and the A end in this direction, or there are forces that are acting on the A and B end in this direction. There are only 2 forces. Trusses are made up of members that are completely made of 2 force members. Now that's important. I mean, later in maybe a week or week and a half or something like that, we're going to talk about frames. And one of the differences between trusses and frames are frames can have more than 2 forces. Okay. Trusses are only loaded at the joints. They're only loaded at the joints. So if I was looking in here, for example, some of the problems we might work, you might see a force at C. You might see a force also at B. What you will not see, so if you're taking notes, don't draw this on your picture. I'm going to draw it and then erase it. What you will not see is a force that is applied to a member not at a joint. So this force that I'm about to circle, I promise you I'm getting ready to circle it. This force that I just circled that is not applied to the joint, we won't see that. Right? Trusses are only loaded at the joint. So I'm going to erase that so we don't get confused. Okay. Each member is either in tension, in other words, it's being pulled apart, or it's in compression, or it may just be there. It may be a zero force member. Oops, that's not the right color. Might be a zero force member. In other words, there's no force being applied. And we will certainly see that later in the chapter, and hopefully we'll be able to use that to our advantage. So they're only loaded at the joints. The member is in tension, compression, or zero member. The weight of each of the members is considered negligible. So we won't see any problems that say you have a truss like the one pictured. There is a pin joint at support at point A. There is a roller at point D. The member EC weighs 10 kilograms. Not going to happen. In trusses, the weight of the members are considered negligible. And that is because trusses are lightweight in comparison to the load that they carry. So they're fairly lightweight in comparison to the load that they carry. The last characteristic that we need to talk about are how the members are connected. The members are connected at their ends to form joints that behave like frictionless pins. So for example, what connects member AB and BC and BE all together at point B is a frictionless point. Point E, that joint holds those members together by a frictionless pin. Point C, frictionless pin. The only difference would be if they're being supported, right? So in this example, I think I said that A was being supported by a pin connection, D had a support of a roller. But the rest of the joints all behave like frictionless pins. So I'm going to pop out of this video to get ready for the next video. See you in a couple minutes.